If just in cases where it's easier to calculate those, but that would be pretty rare. But yeah. Okay. Today, the second one. We're not even going to go through a PowerPoint. We're going to straight to the problems. Okay. Solving problems involving exponential variables. Okay. So, what we want to do is get the base with the variable exponent alone on one side. Then we're going to log or natural log each side to solve it. So, how do we get 1/3 x to the basically 1/5 x alone on one side? Divide by 45. 5 over 45 is 1/9. So 1/3 x over 5 equals 1/9. Now, what we want to do is get the same base on each side. So 1/3 to the x over 5 equals 1/3 to the what power? Second power. Because 1 times 1 is 1, 3 times 3 is 9. Now that we have the same bases, we drop the bases. X over 5 equals 2. How do we get x alone? X equals 10. So if you plug 10 in here, you can see that 10 over 5 is 2. 1/3 to the second power is 1/9. 45 times 1/9 is 5. It checks. Okay? Let's do the same thing on the next one. Okay? Divide by 2. So 3 to the x over 4 equals 81. What's my base going to be on each side? 81 or 3? 3. So 3 to the x over 4 equals 3 to the what power? 3 to what power equals 81? Well, we know 3 squared is 9. 3 to the third is 27. So 3 to the fourth power is 81. At this point, we drop the bases. X over 4 equals 4. Multiply by 4. 16. First step in this next one. Divide by 4. So 3 to the negative x over 5 equals 3. We're already set up. But what's my exponent on my right-hand side? On my right-hand side?
Or like 1.
1. So negative x over 5 equals 1. So negative x equals 5. So x equals negative 5. Easy peasy lemon squeezy. Now, solving logarithmic equations, and we've done this already. This is base 10, right? So 10 to the third equals x. So x equals 1,000. So what would be the logarithmic equation for this second one? 4 to the
First power.
negative second power equals x minus 3. 4 to the negative second equals x minus 3. This to this power equals this. So 4 to the negative second is 1 over 4 squared equals x minus 3. 1/16 equals x minus 3. Add 3. X equals 3 and 1/16, or 49 16ths. Same type of layout for this one. So what to what equals what? 4 to the negative first equals x minus 5. So 1/4 equals x minus 5. Add 5. X equals 5 and 1/4, or 21/4. This next one is a calculator problem. 1.43 to what power equals 4.6? Okay. Simply, we log both sides. Log of 1.43 to the x equals log of 4.6. Now, what we learned in the first lesson this morning is the power rule. X log of 1.43 equals log of 4.6. And we divide by log of 1.43 to get x alone. I don't know what the log of 4.6 divided by the log of 1.43 is, but it's what you did for the what?
4.267.
So if you took 1.43 to the 4.267 power, it'd be somewhere really close to 4.6. That's what we're doing. That's a basic use of logs today, is getting exponents out, or getting variables out of the exponent. Okay. For this one, before we do the log or anything like that to both sides, what should we do first? Divide by 100. Let's simplify first. So e to the 0.098t equals 5. Now, because there's an e, we're not going to log both sides. We're going to natural log both sides. Because e and ln's are reciprocal functions, or inverse functions of each other. So 0.098t equals the ln of 5. Divide by 0.098.
Would it work if you graphed it?
Would it work if we graphed it? Yes. You graph, well, no, because you got to get t. Well, I guess it would. You graph the left side, graph the right side, find out where they intersect. Yep. That would work. 16.423. Okay. What would you do on number 9 first?
Subtract 15.
Subtract 15. So 2e to the negative x equals 15. Then you divide by 2. E to the negative x equals 7.5. Then you natural log both sides. Negative x equals ln of 7.5. And divide by negative 1. Whatever the natural log of 7.5 divided by 1 is, then you get it. Says state the domain of this function. What I would do is graph it first. 2 ln of x is twice as high as a normal natural log, which I think would be this one. You'd have to graph it to see which one works, but I think it's that one, because it should cross here at, yeah. Well, it could be B. I don't know. It's one of those two. And then to figure out the domain, you look at the graph and say, well, nothing can be negative here. So it must go from 0 to infinity. Now, what's the natural log of 0 on your calculator? Error, right? Okay. That's why there's a parenthesis here. Okay? If I'd make it a bracket, that means we could use 0. Okay, we can go really close to 0, but we can't hit 0 on that. All right, this last one. How would we solve this equation?
10 to the 6th equals x.
Right, exactly. This is log base 10. So 10 to the 6th equals x squared. Take the square root of each side. X equals 10 to the 3rd power, because the square root is taking half the power. Half of 6 is 3. So it'd be 1,000. Okay, so I will put out, there's an 11 problem assignment. I will put it out. Miss Astus.